So we're going to start Unit 5. So if you bought a textbook, this is a whole new book. In this whole semester, we're going to be talking about trigonometry and studying angles. So some of this stuff you may be familiar with, some of it may be new. I'm going to pretend like it is all new. So this first packet is just on angles. And so you learned all about angles in geometry, but most of the time the angles you were learning about were like inside of a polygon or something like that. So we're going to think about an angle as rotating a ray about its endpoint. So there's different parts to these angles. And so the initial side is the starting position of the ray. And the terminal side is the ending position of the ray. Right? And so if you look at this one over here, I'm going to see if I can do it. I'm not really sure. So here is the initial side, and then you rotate the ray around, and then you end up the terminal side. And so all that space that traveled in between, that's considered to be the angle. All right. The vertex is the end point of the ray. And we're going to think about our rays or our angles being drawn in the coordinate plane. And so standard position is when the origin is the vertex, so 0, 0, and the initial side is the positive x-axis. Right? Now, all positive angles are going to have a counterclockwise rotation. All right, so that one that I drew a second ago, that is considered a positive rotation. That would be a positive angle. And then negative angles have a clockwise rotation. All right. Now, coterminal angles is probably a new concept for you, but I'm really not sure. But coterminal angles have the same initial and terminal sides. All right, so this angle is drawn below, positive 135 degrees, but that angle could also rotate in the negative direction. So it still started at the positive x-axis. It still ended at that same terminal side, but it's a different angle. Any ideas on what it would be? Well, that angle is negative 225 degrees. And to do that, I just took the original angle, and I subtracted 360 from it because there's 360 degrees in the angle. All right. Then for this other one, so this one, second one, is negative 60 degrees. It's rotated in a negative direction, but there is a coterminal angle that's rotated in the positive direction. And that one is going to be 300 degrees. So same thing, I took that negative 60 and I added 360 degrees to it. Okay, so those two were in degrees. There is another measurement that is even better, really. Degrees you are the most familiar with. But the other measurement is good whenever you want to use it in a formula to figure things out, like arc length or area. So degrees, we all know, because I just talked about it, and you probably knew before, that there are 360 degrees in a full rotation of the circle. Now, there's a new measurement that is called radians. And 1 radian is formed by laying the radius of the circle onto the circumference. Okay, so we can see that this circle, this is the radius, it's the length of the radius. So what they did is they took that same length and they put it along the edge of the circle. And this angle that's formed right here is 1 radian. So 1 radian is way larger than 1 degree, but that's how it's formed. Okay, so I'm going to do some more. I'm going to try to. All right, so now I'm going to take that same radius. I'm eyeballing it, so it probably is not going to turn out perfect, but we'll try. And I'm going to lay it on the circle. Let me stop about right there. Okay, so I'm going to draw a straight line from the origin to that, and that's going to be 2 radians. All right, you guys go ahead and draw it too, please. Okay, then I'm going to take that same length again and put it on the edge of the circle. You'll go about to right there. All right, and that's going to be 3 radians. All right, and then I also know right here is 3.14 radians. All right, so I'm going to do it again. I'm going to take that, the distance of a radii, or radius, and I'm going to lay it on the circle. Let's see, I would say it'd be about right there. Might be off a little bit, that's okay. That's going to be 4 radians. All right, lay another radius on there. That's going to be 5 radians. That's going to be 6. And then here is going to be 6.28. So what do you think that 3.14 is? It's definitely pi. And 6.28 is going to be 2 pi, and that's significant because there are 2 pi radians in one circle. All right. And then we're going to talk about revolutions kind of towards the end of the packet. But a revolution is a full rotation. Of a circle. Okay. So one thing we're going to be doing today is going back and forth between degrees and radians. So we can use what we kind of just figured out. We know a full rotation or 1 revolution originally we said was 360 degrees, but then we also know that is 2 pi radians. All right. And then if we're not using revolutions, like we're not really going to use revolutions today, we're just going to be dealing with degrees and radians, we kind of use like a reduced version that 180 degrees is equal to pi radians. All right, so let's look at the next page. So special angles are multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees, and they are common. And so it's really good if you would familiarize yourself with these angles and like where they would fall on this circle. So where the positive x-axis would be is 0 degrees, so that is 0. All right, and then if we're just kind of looking at these special angles right here, the next one is going to be 30 degrees. And then 45 degrees, and then 60 degrees. And then everyone knows what a right angle looks like. So from 0 to this one here is a right angle, so that's 90 degrees. Okay. And the rest of these are going to be multiples of that. So you guys take a second and fill in what angles you think that you know already. Just knowing that they're multiples of 30, 45, and 60. And so pause the video, and then when everyone looks like they're ready, we'll start it back up. Okay, so check your angles with mine. Those are the special angles, and we'll see them a lot. All right, and knowing these angles in radians is also extremely helpful. So to convert from degrees to radians, so well, 0 degrees is also 0 radians, so we'll just go ahead and put that. But let me use a different color. But and we already know that this is pi and this is 2 pi radians because we already figured that out a second ago. We can figure out the rest of them by converting. So we'll take 30 degrees, and to convert degrees to radians, you multiply by by pi over 180. So this is like 30 degrees over 1. So the degrees is on the top. The degrees is on the top. So if I want to cancel degrees, I need to put degrees on the bottom of the other fraction. So it cancels. Now it also cancels the 0. So a degree and a 0 cancel. So then you kind of just need to reduce the fraction 3 over 18. So that's 1 over 6. So that's 1 pi, or just pi over 6. That's 30 degrees in radians. All right, and we'll do the same thing for 45 degrees. It's slightly more difficult because the 0 doesn't cancel out. All right, now you can use a little blue calculator, a calculator that's not smart, to do this. So we would do 45. And so I know that they both reduce by 5. So I would reduce 45 by 5 and get 9 pi on the numerator. And then 18, you can use or 180, sorry, divided by 5. You can use the calculator or your brain, whatever. You get 36. And then I know that reduces again. Both of those reduce by 9. So that should give you pi over 4. So that is 45 degrees in radians, pi over 4. Okay. And you can do 60 degrees. Right, same thing like we did with 30, a 0 and the degree symbol cancels out. So you're left with 6 over 18, or 1 pi over 3. All right. Now 90 degrees is half of the way to pi, so it's pi over 2. We could do it the conversion way also, but we don't have to. All right, let's look at 120. The 0 and degree cancel. And then we can reduce 12 over 18 to 2 pi over 3. Okay. So you guys pick 1 or 2 to do on your own. And then look up here and check back with me and make sure you get all of these right. Okay, pause the video if somebody needs more time. Now, if you notice, all the ones that kind of correspond to the 30-degree angles, they're kind of 30 degrees away from the x-axis, their denominators are all 6. Right? All the ones that correspond with the 45-degree angle, all of their denominators are 4. And then for the 60, all their denominators are 3. All right, now we're gonna be working with these ideas of these angles for a very, very long time. So just kind of seeing the pattern is gonna help you in the long run for sure. All right, so on example 1, we have this circle and we're gonna label these angles. And not all of these angles are going to already have a line drawn there. So some of them we're going to have to draw our own line. So negative 45 degrees. So I know the 45-degree angle is this angle that covers this much space. All right, that much of a rotation. But this one is negative 45. So it's going to be that much of a rotation, but in the negative direction. So it's going to be right there. Okay. 100 degrees isn't on here. So, but I do know that 90 degrees is this angle right here. So 100 degrees should be slightly larger. Right there. All right, and it's going to be, we need to draw the direction of rotation. So it's a positive 100 degrees. So it's in the positive direction. Draw a little bit better. Okay. And then negative 150 degrees. So if I look back up at my angles up here, this is a positive 150-degree rotation. So we're going to do that same amount of rotation, but just in the negative direction. So it should be this angle right here. All right, and then lastly, negative 5 pi over 3. So if I look at these angles, positive 5 pi over 3 is this amount of rotation. So we're going to do that in the negative direction. So it is going to be this amount. Right now, when you guys go to do that problem, I put it on the back of the packet. So you don't have to flip over there now. I just want to show you. So you have some to do, and I have that drawn for you. So you can just do that on your packet instead of drawing the circle yourself. Okay. Now we did several up here where we converted from degrees to radians. Number 2, they're asking you to convert from radians to degrees. So we're going to take that 5 pi over 12, and we're going to multiply it by a fraction that cancels radians and turns it into degrees. So since we want to cancel radians, we put radians on the bottom and degrees on the top. All right. So the pi cancels. Now radians doesn't have a unit, so there's really not a unit to cancel, but the pi cancels. And then you are just going to use your little calculators, and all we have to do is do 5 times 180 divided by 12, and that's going to give you 75 degrees. Okay, so when we're going from degrees to radians, you multiply by pi over 180. Whenever you're going from radians to degrees, you multiply by 180 degrees over pi. All right, so for example 3, we are going to find coterminal angles, and our angle that we want to end up with needs to be between 0 degrees and 360 degrees. All right, and so what we're going to do is just keep adding or subtracting 360 degrees until it's in the correct range. So if it's bigger than 360 degrees, because we need angles between 0 and 360, if it's bigger, then you're going to subtract. If it's lower than 0, then you're going to add. So in this first one, we're going to subtract. So we subtract 360 degrees one time. It's not quite small enough. So then we'll just subtract it again, and we get 150 degrees. So what that means is 870 degrees goes all the way around twice and then stops at 150 degrees. So their starting angle, their starting position and their ending position is the exact same, but they're different angles. Like 870 is way bigger than 150 degrees. Like it's going around a whole bunch of times. But their starting and ending are the same. So they're coterminal angles. Okay, for B, it's negative. So that means we're going to add 360 degrees until we get something between 0 and 360. And so 1 time's not enough, 2 times is not enough, 3 times is not enough, 4 times, finally, we get 240 degrees. All right, so what this one means is that you're going to rotate in the negative direction around 4 times and then stop at 240 degrees. So they have the same initial and terminal sides, but they're different angles. One is a whole lot of swirlies, and one is just directly to 240. Okay, now we're going to do the same thing. This one is going to be more challenging because we're not using calculators that are very smart. And so we're going to have to deal with adding and subtracting fractions. But we want this angle in radians. And so we are going to, this time, add or subtract 0. Sorry, add or subtract 2 pi. Okay, now what we're actually going to do is just really in our heads add or subtract 2. So anyway, so this one is 19 fourths. So it is too big. So we're going to subtract, and we need to subtract 2 pi from it. But we want 2 pi to be some sort of fourth. All right. And so 2 pi is the same as 8 fourths. Because when we do 8 pi divided by 4, it's 2 pi. So we're going to subtract 8 pi over 4. All right, so I subtract that one time, and I get 11 pi over 4. So that's still too big. So I'll subtract it again. So 11 minus a is 3, so that's 3 pi over 4. That's what we're looking for. Okay, so let me show you what's going on this one. All right, so 3 pi over 4 is here. So 19 pi over 4, we're going to go around, and then stop. All right, so same initial and terminal, just different angles. Those are coterminal angles. Right, and then for V, we are going to add 2 pi. But we have to add it as a fraction that has a denominator of 6. So think about what you think that would be. So 2 pi is the same as 12 sixths, or 12 pi over 6. So when I add that one time, negative 17 pi over 6 plus 12 pi over 6, that's negative 5. So then when I'll add it again, and then negative 5 plus 12 is going to be 7. That's what we're looking for. All right, so that's it for that first day. So if you look on the back, this is going to be a 3-day packet. So you have some problems, or one problem to do here to graph on the circle, and then these are in the book, and it's posted on Classroom.